Hello all and welcome back. So in this video, let us quickly solve insert at tail recursive. Pretty sure you have tried the same out. So in recursion again, you're just going to follow the framework. The very first step is going to be base case. Then we will just ask recursion to do the work. Recursion call. And the last one is our work, right? So if we quickly see this base case, I think is pretty straightforward. If your head again is null, if head equals none, then we can just return the new node, right? So that's the base case. If the linked list is empty, and that is going to be the base case majorly linked list, just like it used to be in array, like the size is 0, right? So we used to take it like that. So return new node. Now coming to this, either we can do our work first or we can ask recursion to do the work, right? So again, it can be done in any way. If we are calling recursion, then we can assume that it's gonna get added, right? If we are not the tail, okay, if let's say just single element is not present, then we can assume that recursion is going to do the work, right? Great. So let us now make sure that we do this recursion call. So pay attention everyone, what we are going to do here. Let's say we do our work first. So if my head dot next equals to none, so that means that I am tail, implies we are tail. So that is going to be our work, everyone. We are tail. And we are just gonna add a new node. Else we will just call recursion. So let us do this, everyone. Else we will call recursion. So let's write it here and we will test it out as well. Okay. 1 second. Yeah. Cool. So this is it. We have the first case, which is if head is, you can also write it like this, if head is none. Okay. So let us make a new node. So new node is equals to node of data, and we can just return this new node. So this is just our base case, everyone. I hope all of you are able to understand this. Empty linked list, whatever you are asking me to add, that is going to be the head only, right? Second thing, if I am the tail, if head dot next is equals to none, this implies I am the tail, right? Now, if the element which we are on, let's say if there's a single element and we are just the tail, I don't think we need to call recursion even. What we can do is, again, let us make this node. We can make it outside as well, just making it inside function when needed. And we can say head dot next is equals to new node, right? So if that's the case, then we have handled it. If not, then what we have to do, that is where a little bit case of this function lies. So let us just copy this particular list. Again, just a second. 1 second, everyone. Let me just copy this. Again, this is the same one. 1 second. Yeah, sorry. Great. So just let's say copying this whole thing. And let me bring it down here. Now pay attention, everyone, what's going to happen, right? If we have done this way, where I'm saying that I'm calling on recursion. So we have already seen how the call happens to recursion. We just break it here, right? Now, it can very well happen that recursion is making some changes into this head. So this is going to be the head of recursion, right? And I have already told you this, that we make sure that either we are making the changes, if we are sure always that head is not going to change, then we just make the changes in our function and we can not return anything. But if there is a little bit of chance as well that head can change, okay, then we have to make sure, that we are returning that head. In this function, there is a chance that head can change because 1 second, yeah, as we have seen, just a second, everyone, let me just reorder it. Yeah. So as we have seen, If head is none, then it is getting changed here. So I have to make sure that I return this, right? So that's why I'm returning this new node here. Now in this particular code, if we have handled it, that is fine. But if I'm making the recursion call, I have to make sure that I connect it back to my head, because I cannot say that the same thing is going to get returned here. So this particular connection, I always have to make sure that I update based on what recursion is giving me. So if let's say this is the case where recursion is giving me something after updating and say head itself has changed, then I have to always make sure that I make this connection again. Okay, so let me show you this everyone. So what going to happen? We are going to call insert at 8 recursively, but this time head dot next and the data, right? And we should be good to return our head. Now in this particular case, because we have made sure that we have handled this case where head is none, so we are working like this. Let me return head here. Okay, this case will not happen, but in future recursive calls we are going to see. Okay, let's say if you are asking recursion to insert at this position only and you ask recursion to do the same, then recursion will give you the new node. Recursion is going to give you the new node. So that's why it's always preferable to make this connection again. Whatever recursion is returning, just make the connection again. If it's going to be the same head which you passed, head dot next, fine, no problem. Okay. So let us run this everyone. Let us just try to run this. Insert at tail recursively. Cool. So first is your 10. I entered 0, no worries. 20, 30 and -1. So it's saying 0, 20, 30 and it is able to enter in the last, right? It is able to enter. Let us just run this again once. If let's say it's an empty list, then also I'm able to enter 100 here, as we can see. So this code works absolutely fine. Okay. One more caveat here. So if you just remove all this, it's going to still work fine. It's going to still work fine, right? So why is that? Let us first try to understand exactly what would have happened in this code. Let me just draw on screen to explain you. So let's say if we have just two elements like this, 10 and 20, right? And I am trying to add this as my element in the end, which is say 30. Okay, great. So we will first start with seeing if head is none. I don't think our head is none. So we are gonna we are gonna just check for this particular case if head is tail as well. Both the cases are not right. So I'm going to call recursion on this, right? When I call recursion on this, this is will be the new head. Now, first I'm gonna check if head is none. No, it is not. If head is tail, well, yes, head is tail. So I'm going to make this connection. So let me make this connection. This is what we are saying, right? Make a new node. Head dot next is equals to new node. This is the connection. And this anyway is none, so we should be fine here. Right, everyone? So this anyway is none, so we should be fine here. Let me just draw it in white only so that you can understand. This is none, so you can understand, right? Great. Now, once I return it, this head is going to get returned. This was the head we are returning, and we are just reforming the connection. Okay. Now the reason, if we remove this and it works, let us understand this as well. First, let us see if this will work or not. Let's say 10, 20, 30, -1. See, it is working. Okay. And if it is, let's say just -1, again, it's working. So yeah, it is again very important to understand. Let us see everyone. If let's say you have, 1 second, yeah. If let's say you have your linked list like this, say this is 10 and this is 20, right? Now let's see how the call is going to happen. This is head. Is the head none? No. So I'm saying that, hey, whatever you get, I'm just gonna remake my connection. So you call on this 20, right? You're calling on the shorter list, linked list. Again, you have to do all this after writing the code. We have already seen that how we don't have to go into recursion. We have to just apply PMI. Now I'm gonna check if this is head, this is none. It is not. So I'm gonna make the call to the head dot next, which in this case is none. Now when this head is none, what I do, I create a new node. I create a new node, okay, with value, let's say 100, this none, and I return this, okay. Now you can understand that why this line is important. Earlier, for this particular head, earlier, this was none. But now I am remaking this connection and saying that, okay, whatever you are returning me from this call, which in this case is going to be the new node, I'm gonna connect my head to this. And that's why this gets connected. Then I return my head. This connection gets made again, and we are able to return and work this out. Right, everyone? Because here the base case is able to handle this adding of your node. But again, please understand, if I don't do this, if I just remove this working, right? If I don't do this head dot next, then it's going to become null, and I'm not actually taking advantage of what has been returned. Okay. So yeah, great everyone. I hope this is clear. This was a little caveat in recursion in linked list. Again, this is the first question. If you were able to try and do it, very nice. In the future also, we will be doing many questions and operations using iteration and recursion. Okay. So yeah, great everyone. Let's meet in the next video. Thank you.